Welcome. In this video I'm going to show you how you can determine the Wilcoxon signed rank distribution using Microsoft Excel. The easiest way would be to actually use my StickPad E add-in, I think, which has a separate function for it. But in this video I'm going to show you how you can do it without that and using the enumeration method. I have a separate video on the concept of this distribution, so I won't be explaining too much about that. The enumeration method is actually just listing all the different possibilities and then checking the counts for those. So let's dive in. The first thing we need to do is have the sample size. So I'm using 5 as an example, but you can change that to whatever you want, of course. The larger, the more calculations you will need to do. The second step is then to determine the number of possible distributions of these n scores. So we are assuming we have 5 different scores, each being unique, so they each have a unique rank. And the number of possible ways we can then actually have a sum of ranks will be simply 2 to the power of that sample size. So that's going to be 2 to the power of 5. Then we need to create a list of all the values ranging from 0 2, and then our number of distributions, -1, because 0 actually counts as 1. So that's what I've done over here. It starts at 0, and I simply keep on adding 1 until I reached all the way to 31 in my example. Then I convert these to binary numbers. So that's the next step, step 4. And Excel actually has a function for that. It's called des for decimal, 2 to binary, and it simply converts each value to a binary number. So as you can see, I copy pasted that formula all the way to the last one, and the last one is then all the ones. So a 1 would then indicate that this is actually being used, and a 0 means it will not be used. And that's what's done actually in the next step. Step 5 is simply to list all the numbers from 1 to n, so that's what I've done over here. 1 to 5 in my example, and then the big formula is actually the next one, which is to split all those binary values and then list them horizontally. So for example, an easy example would be, for example, this one with 18, that's 10010, and what I'm going to do is then simply say 10010. So that's the same result. Yeah? You should actually read this the other way around. So it's 01001. So 01001. All right. Now you might notice that here it's easy because I actually have 5 digits. Here there are no 5 digits. There are only 2. So what this formula does over here, and it's the first one, it first checks actually if the length of this one is less than the value here. If that's the case, then it will actually simply put in a 0, because that means this value is not in there. Then, if it's not, then it will actually simply look at the leftmost digit of starting from the right, this digit from this text, and then I want the first digits. So if I copy paste this down, it will give me the second digit, so that's going to be then for this 10, it's going to be this 1 if it's in the second one, etc. And then it should actually just give me the first, because I only want 1 digit. So this splits up as mentioned earlier. So here it's all zeros, here it's a 1000 because there's only a 1, and this 10 is actually 01, reading from right to left. So that's what's done here. So you can actually copy paste then this formula. Alright, that's the biggest step actually. After that it's fairly easy. What we do is, for example, this one would mean that this rank is being used, this rank is being used, and these are not. So I have a 1 and a 2, and if we sum that up, we get this 3 over here. Now we can use Microsoft Excel's sum product function, which basically says multiply these with this and add the results. So that's what sum product does. I blocked with the dollar signs in here this range because it needs to be every time these range from 1 to 5, and the dollar sign prevents this from actually being changed. I can then copy paste this one all the way to the right, and that should give us all the different possible sums. Alright, so that was already the step 7, sum for each option the ranks used. Now we're going to look at all the different possible sums, and this range is actually the same as 0 to n times n plus 1 divided by 2. So that's, in my case, that's 15. So I simply rank them here 0 to 15. And just to check that 15 is indeed, if you want to see, that 5 times, and then that same 5 plus 1 divided by 2, that should give me the maximum possible rank, which in this case is 15. Alright, now that I've listed all the possible options, then I can simply count how often each of these appear. For that, I can use the count if function. So I'm going to count if in this range, all those rank sums, if it's equal to the rank sum given here. So that gives me the frequency table actually of all of them. And then we can finally add our probabilities, which is simply then the count divided by the sum of all of them. However, that should be the same as this value that we have over here. So I can simply say, well, this is going to be the count divided by the total number of possible distributions. And then I can copy paste this one all the way down. For the cumulative probabilities, the first one is simply the same as that one, so that just stays like that. And then the next ones are each time the previous cumulative one plus the current probability. So it's the current one plus the previous one, and then I can copy paste this one all the way down, and that gives me all the cumulative probabilities. So if I have a sample size of 5 and I have a sum of ranks of 6, then there are 3 different ways that that could have been achieved. That's a probability of about 9%, and to have a rank sum of 6 or less, we'll have a probability of about 41%. Alright, that was it. I hope this was helpful, and thank you for watching.